MemoRizz is a bad name. It's a joke. I was trying to prove a point, and I was trying to be cool. I was trying to prove a point to some of my colleagues and teammates on where the space of agent memory is going. And I created a library around about a year ago. And I created it so that I can essentially communicate in code where I see a lot of agentic engineering going towards. So most of you will know at a high level what I'm talking about. Some of you might have already heard some tools like mem0. Anyone heard of mem0 here? Put your hand up. 2, that's good. Like 0.1% or something. Anyone heard of LangMem? No? LangGraph? Anyone heard of LangGraph? Yes. Anyone heard of LangChain? Yes. Okay. So LangMem is the memory management layer built by the team at LangChain. So you can check it out. So everything I'm talking about today, there are teams in the front line that are exploring how to really make agent memory work. So maybe the reason why you've not heard of LangMem is because it's still in development. But a lot of people have heard of mem0. They just raised another big round recently. Anyone heard of memGPT? Yeah, that's good. Letter is the commercial name. That's excellent. So my name is Richmond Alake, and today I'm going to be talking to you about memory engineering, and I'm going to be talking to you about memory engineering through the library that I built called MemoRizz. So the way we're going to split this workshop is hopefully the timing works. We're going to use 30 minutes to talk about memory engineering, agent memory. We'll start from high level, then we'll work our way down into the technicalities of it. Then we'll spend the rest 1 hour, 30 minutes really going through some code, and hopefully the code works as well. And you guys can also follow along. There's a bunch of instructions. The repo is open source, and I will show you the notebooks where you can follow along. And if things don't work, I can come over and help you and guide you, or you can do this in your free time and reach out to me on LinkedIn, and we can talk about agent memory and memory engineering and pancakes. I'm a big fan of pancakes. I know the best pancake spot in the UK if you ever visit, and I'm open to recommendations for New York. So let's start. What are you going to learn from this workshop? A lot of it is my propaganda, which is fair. Well, it was propaganda last year. This year is people are starting to see where the space is going. So we're going to understand the architecture of agent memory. We're going to understand different types of memory. We're going to really bring this high-level concept of memory that we've been hearing a lot. Folks at Google recently put out a paper called Context Engineering Session in Memory, but most of it was memory engineering and not a lot of context engineering there. So this is really topical, and it's really good to understand why agent memory and what it's actually trying to solve. Then we'll talk about the data to memory pipeline. When does data become memory is a question that a lot of people have asked me. We'll talk about the different memory types. So long-term memory, short-term, episodic, semantic, conversational. And we'll also talk about how we can implement some of these memory engineering patterns. We'll talk about it at a high level, then we'll look at the code and see what we've been able to do with MemoRizz. And we'll build an agent architecture backed by a memory core. And when I say memory core, the memory core that we're using today is going to be Oracle. It's going to be Oracle AI database. So there's a lot of information here today. And I want to get to the code section. In the code, we're going to see a single agent that we're going to augment with memory. Then there's another second coding session where we'll look at like a deep research use case, where we'll get an agent that can generate a bunch of reports and spawn other agents. So we'll go through this, and there is one worry. Can I share with you the one worry that I have? I am going to be running through the code, but I feel like this is too small for you guys to see. So hopefully we'll figure something that works. If not, all the code is online, and you can follow along. So let's get started. Number one, AI agents. What's an AI agent? Has everyone heard about AI agents, right? Hands up if you heard of AI agents. Excellent. And I'll guess the ones that didn't put your hands up, you're just too lazy to put your hands up. Because agent. This year is like, who said this word? It's the decade of AI agents. Who said it? I think Andre Karpathy said it in a podcast. It's the decade of AI agents, and I agree. So what's an AI agent? Well, an AI agent is a computational entity that basically can act independently. That's the goal. It is backed by some form of LLM, and the LLM helps it with its cognitive abilities, which would include reasoning. It also can take actions through tool use or function calling, and it also can perceive its environment, right? But the most important part of an agent is it is augmented by memory. It has a form of memory. Now, I'm biased. I work in a database division within Oracle, and I've worked in different other database companies. But my bias or my opinion is you can't have an agent without memory. It's like the way I try to describe it. It's like, how many of you have ever bought a house before, or even just rented one? Hands up. Great. So imagine you're like a estate agent, and you were telling them. It's Monday, and you told them the type of house you wanted, the budget, where you'd like to live, your family size, what you like to avoid, and all the good stuff. Then this is on Monday. Then you get to Tuesday, and you meet the same estate agent, and they forget who you are. You have to reintroduce yourself. And you have to tell them your budget, where you like to live, and your family size, and things you like to avoid. And then you get to Wednesday. You meet the same estate agent, and they forget who you are. And you have to repeat the same thing over and over again. That gets annoying, right? You're not going to use that estate agent. Well, the same goes for this computational form of agents. They're meant to act independently, eventually act on our behalf, so we need to make them more reliable, believable, and capable. So we need to make them actually perform in production, and the way that I think we should be able to do that is by, obviously by having better models, but also by having a form of memory, augmented memory that is connected to the agent. Okay, so that is what's an agent. A computational entity backed by memory, has perception of its environment, can take tools, and has reason abilities that is provided by an LLM. There was once a time where we couldn't agree on the definition of an agent. Does anyone disagree with my definition of what an agent is? And don't be shy, it's fine. This is a conversation. You disagree. Why do you disagree, sir?
It's not really your definition, but do you really believe that they can reason?
Do I agree that they can reason?
Yes. Do we think it's actually reasoning, or is it just something that kind of looks like maybe?
It kind of looks like reason. It's mimicking reason. But let me ask you another question. How do humans reason? Poorly, yeah, especially me, but how do humans reason? Like, can you explain it to me?
Evaluating like alternatives of like thinking, in the sense of like comparing concepts.
Then that's good. A better question is, do I need to stay so the camera can see me? No. Oh, okay. Oh, the mic. Excellent. A better question. Do you think humans understand how the human brain works 100%? We don't. Neuroscience is still an active field of development. We don't essentially know how our brain works as well as we know other parts of our body. But I do agree with you. LLMs are just mimicking, it's just next token prediction. But hey, mimicry is the best form of flattery, so. Okay, but yeah, fair enough. But that's not, if I was an OpenAI, maybe I'll be able to rebuttal that a little bit better, but I'm in Oracle, so let's go. Use cases for AI agent. Workflow automation is the most popular one. There's a bunch of processes that we have in some of the systems and pipelines or some of the tools we use today, and some of them can be very manual. One thing that we have agents, and we've used agents for, is to automate workflows. So the agents can essentially take decisions that based on some heuristics or some guardrails or something that it's internal to it that has been provided by a human to then make the right decision. Then we have research and analysis agents. So within ChatGPT and within Gemini, you can go into deep research mode and you can give it some instructions and it will ask you for some clarifications, and then it will go off to the internet and it will do a bunch of research and analysis and be able to give you a final report. So deep research research and analysis agents are very common, and it's a very useful use case for AI agents. Then you have data knowledge retrieval, you have coding and software engineering agents. I'm a big fan of Cursor, I use Cursor, so that could be an example of coding agents. Then there are customer supports and service agents that we have in most of the customer facing industry or applications that we have today. So again, personal productivity agents, I use Notion as well, and they have this little AI assistants that they try to get me to use that I don't really use, but it's there. But so there are different types of agents, there are different types of use cases for AI agents. But in all of the variations of AI agents, there are some common patterns or common use cases, and I call them application modes. So there are common application modes in AI agent. The first one is assistant, right? Back and forth conversational assistant AI agent, and it would typically respond to your query, and it doesn't need to have a robust knowledge base. And you can think of this as ChatGPT. ChatGPT is a good example of an assistant. The next one is workflow agents. The best way I can describe this is, how many of you have used the tool NA10? So NA10 is used to construct a bunch of workflow, then you can automate it. But you can actually do most of this programmatically, so you can actually have typical, you can use LangGraph to build a workflow, to construct a workflow, and have it be LLM driven, essentially. And it would have sequential steps or processes that would execute either sequentially or in parallel. So that's workflow. Then we spoke about deep research, right? Deep research, I've explained it already. So these are the three common application modes I'm seeing: assistant, workflow, deep research. Assistant, workflow, deep research. So again, does anyone disagree with me, or can anyone add other sort of application modes that you're seeing? Do you all agree that this captures a general pattern then? Hands up if you agree.
Question.
Go on.
Where would you put coding? It feels.
I'll put, oh.
Where would you put coding assistance into that? Because it feels deeper than workflow, but not quite research.
Yeah.
It sits
So
between.
what was the start of your question? Repeat it.
Where would you put coding agents into this taxonomy?
Okay, so I will put coding agents into the assistant column. So earlier this year, I used to think you're either one or the other. You're either an assistant, or you're either a workflow, or you're either deep research. Then I sat with a professor based there in New York. He came to London, and we're having conversation in the UK about data and agents, and over pancakes, obviously, is how I have all my conversations. And he changed my mind. He said, Richmond, you shouldn't see it as so binary, right? An agent can fall within a spectrum of these application mode. So it's just the level of the application mode it has. And it got me thinking, you can almost imagine it as, does anyone know the Myers-Briggs personalities? Do you guys know it? Yeah, good. So I am INTJ, which is like the architect. Rightfully so. But human personality, you're not just one or the other. There's a scale of different characteristics, and that's why I looked at it. So earlier this year, you're either one or the other. Now, it's a spectrum, right? It's different characteristics of this. So to answer your question, Where would you put a coding agent? Well, a coding agent is going to have, it's not going to have deep research for sure. It's going to have a bit of the spectrum of assistant and workflow. A coding agent can traverse through a bunch of files and can search the internet, but deep research is extensive. It goes into different online sources, then goes within nested links and all the cited links within the initial source link. So I wouldn't put a coding agent within the deep research column. So I would say it has a balance between assistant and maybe some workflows as well. Again, this is a conversation. I love it when people disagree with me. This is how I know I'm doing a bad job. If everyone agrees with me, that means I'm doing a very terrible job. So please, let's learn together and grow together. Agent memory. So we're here at the key part, and I'll try to be on time here, so 10:25. And I can see my internet is died, so I'll have to connect to the one that Alan told us to connect to. But I will do that when we get into the code, not now, because the slides are loaded, they work offline. Yay, Google. So agent memory. So I'm going to define, in this section, I'm going to define what agent memory is. We're also going to talk about the different types of agent memory. And I'll give some very high-level description, but when we get to the code, it's going to make sense. So I want to start with humans. Humans are a very good example, and it makes it easy to understand what I'm talking about when we get to the computational form of all of the memory types we're going to be talking about. So humans have a very good ability, some anyway, have good abilities to retain, reuse, and recall information. And nature is a very great architect of intelligence. And we've used nature as a blueprint for technology. So if you look at the airplanes, the earlier attempts at building airplanes took inspirations from birds of flight, right, and insects. So the first iterations were devices that mimicked flapping. Again, mimicry is the best form of flattery. We're mimicking the way birds were flying. We didn't end up with airplanes that flap. The plane that took over here didn't flap its wings. It was a turbulent it was a turbulent flight. There was a lot of turbulence, but it didn't flap its wings, thank God. But the key thing is, even within agent memory, we can also look to humans, to the human brain in particular, how it works, how it functions, and take inspiration from it to actually understand how can we augment our agents with computational form of memory. So these are examples of memory in humans. So we have working memory, we have long-term memory, we have short-term memory. So I could tell you my phone number now. I'm not going to do that, but I could tell you now, but you wouldn't remember by the end of this talk, or you wouldn't remember in the next 2 hours, except if you wrote it down. But if you were to repeat it to yourself maybe 10, 20 times, then it will probably go into a more longer form of memory within your brain, and then you'll probably be able to remember. We have episodic memory. We have semantic memory. So we have associative memory. So if I tell you to think about the color red, think about the color red. Okay, I'm going to assume you thought about it. So some of you would have thought about blood, maybe roses, or other things associated with the color red, associative memory. Some of you might have good recollections of birthdays that you've had. That is a form of episodic memory as well. My ones are good, all good, thank God. Okay, so this can help inspire agent memory. And when I used to do this talk, I used to have a bunch of image explaining what agent memory is, and I used to just go straight into it. But now, the past couple months, I've realized that I need to explain what is agent memory very clear. And agent memory has different components to it. So it needs to have an external store, right? Agent memory needs to have an external store. So this is going to be like a database or a file system. But a database, because I'm biased. So you need to have a database. You also need to have, agent memory also consists of the context window of the LLM. That is part of the agent's memory. Because remember, an agent has an LLM that provides it reasoning and cognitive abilities. Then the parametric memory of the LLM that is static, which means it doesn't change, that's also agent memory as well. So an agent has this external database that could be dynamic form of memory has this working memory in the form of its context window, then has this parametric memory in the weights and parameters of the model itself. So those are the main components of agent memory. And memory engineering is all of the code that we write to move information through these components. That's what memory engineering is. So I hope that's very clear. And I've kind of just summarized all the talk in that one sentence. But so we're going to go through the slides. But this is a much better definition of what agent memory is. And agent memory is. And the phrase I find that explains it is that it's a computational exocortex for AI agents. That's how it's best to explain it. And also the way I explained it is also a good way to explain it. And the key thing about agent memory and the aim where we're trying to get to is we want to make AI agents more reliable, believable, and capable. So everyone understands reliability, right? You want to be able to use the same AI agents over and over again, and you can rely on it to give you the right answer. The same way you would go to your doctor and you rely on them to give you the best medicine for a certain disease sometimes. But yeah, capability as well. You want your AI agents to be capable. You want them to be robust and be able to do, you expect them to do what you ask them to do. And you want them to be believable as well. Now, quick question, is believability a word? I should have Googled this before I started this talk. It's a word, right? Hands up if it's a word. Nice, thank you. So the believability of an agent is actually quite important, especially if you have one that is meant to be an assistant, one that is meant to interact with humans. So the latest update from ChatGPT really honed in on that believability factor, right? Because now you can change the personality of, you could change the personas within ChatGPT now. Has anyone tried that out yet? Yeah, I haven't tried that out either. But you can change the personality of ChatGPT now. So that's the believability factor. We're going to look at the memory types that help each of these factors actually work in AI agents. So we're going to go into type of agent memory. So there are three main types: short-term, long-term, and coordination. Coordination is actually quite special because we need it during multi-agent architectures, as we are going to see in deep research mode. So the first aspect of this are the different types of short-term and long-term and shared memory. So working memory is very obvious, right? Is this short-term form of memory. So is semantic cache as well. Semantic cache, we're going to look at all of this in code examples as well. There is procedural memory, which is essentially skills and routines. You can think of information as to what MCP to use if you were to store that information in a database. That would be a form of procedural memory. You can think about storing all the JSON schema of like REST APIs and all the functions you have that you want your AI agents to call. That's a form of procedural memory. Workflow memory. So remember, I mentioned that there's free application mode, and one of them was workflow. So you can actually have the steps that an AI agent takes when executing a task. You can store that into a database or some form of external memory store. And in the next iteration, whether the task was successful or it was a failure, that's experience for the next iteration of the agent. So it can it can actually use the steps that were successful or have reasons for failures and try to avoid that path or take a different path. So that's workflow memory. We're going to go through each of this in more detail. Now, this is going to get annoying because I have animations here that are unnecessary, but I'll click through very quickly. So short-term memory. Short-term memory is there are different types of short-term memory, but the key thing here is they don't last long. They're not for long horizon tasks. The information stored in short-term memory is meant to be cleared after a certain time, or maybe when seems to be some lack of activity, you would remove the information within the short-term memory. So a very common short-term memory is working memory. So then we have long-term memory. Long-term memory, as obvious, is meant to persist through sessions. It's meant to persist through inactivity within your application. And you actually want to, you could use long-term memory across sessions as well. And then for coordination, which is particularly shared memory, there's a special type of memory that you need within multi-agent architectures or agents where you have multiple agents working together. And it's just a way to say, hey, I have this external store that is just going to be used for information that is involved within multiple agents talking and all of multiple agents working together. And all of these agents can work within the same memory space in a sense. So it's usually called a blackboard is what you would call it. And you have all of the agents communicating and pulling information in and out of this memory space. Now, there are different ways you can architect communication in multi-agent architectures, but one of the common ways is to have them share context, which obviously, for obvious reasons, it can cause a lot of problems that will lead you into the path of context engineering techniques. Or you can have them just share instructions. So you have a root agent giving only instructions to the sub-agents, as opposed to sharing all the context and back and forth as well. So there are, again, unnecessary animations. I apologize for that. We're just going to go over to just click through. Excellent. So working memory. Working memory are, again, temporary. They're usually, you can think of it as the agent scratchpad. And a good example of working memory is the LLM context window, right? That is a good example of working memory. We're using that context window in the moment as this agent scratchpad to do things like chain of thought, right? That's been done in the agent's working memory. Then session memory. So if you go through, and this is where, I guess, this is how you know the field is still developing. When Google put out their technical white paper, it was very good. I read it on the flight here. It was very good. It covered a lot of information. It also expanded my thinking into some aspects of agent memory that I've not yet considered. But one thing I didn't agree with is they saw session and memory as two distinct things. And they defined it, and to me that was weird because session is a type of memory. You store information within a session. It is short-term memory. And in the paper, when you read maybe several pages down, they do clarify that a lot of people call session as part of short-term memory. But I think, so the one place where I disagreed with the white paper was you don't need to actually separate the two. Session is a type of short-term memory, and then you have other forms of memory. So again, the space is still developing. A lot of people are, the best thing about this, I guess this era of AI and just AI in general is everyone's learning and everyone is sharing knowledge. So a lot of folks in Anthropic, LangChain, Manus, Google, and wherever I am, we share the information that we're coming across when we're trying to make this AI agents more reliable, believable, and capable. And I have to apologize, I have a slight cough. So I'll be coughing occasionally. Let me skip over to semantic cache. So has anyone heard of caching? Hands up, hands down? Okay, that's decent enough. You understand caching while I explain semantic cache. And we're going to see semantic cache in action as well. Essentially, it's a way to reduce the operational cost of your AI agents. So generally, the way semantic cache works is it's a form of short-term memory because you can actually state the time to live for information within a semantic cache store. But essentially how it works is you make, within an iteration, your user or application. Sorry, what's it? It's cough drop. Cough drop. Oh, thank you very much. Am I that bad? There's 3 bottles of water. Excellent. Okay, this is good. All right. I feel better now. Okay, so let's talk about semantic cache very quickly. So when you make a call to LLM, you would typically incur some charge on the API side, right, on the inference side. So you make your call to the LLM, you get your user query, you make the call to the LLM, and you get some response back. But what semantic cache does is it actually stores the query, and it stores an embedding of the query, and also stores the response from the LLM. Because when the user makes, let's say in the next execution, the user makes a similar question. For example, I forgot my password and I can't remember my password, are the same, they would have the same answer, right? And what you would want is, you don't want to go to an LLM to like do the whole work again if you've done it previously. What you want to do is use the cached response, because there is this semantic similarity that you've used techniques like vector search to calculate the similarity between the two queries, and you've noticed that they're quite similar, so you use a cached response. That's a semantic aspect of semantic cache. So next is procedural memory, right? We've spoken about this, I'm not going to go over it, but it's skills and routines essentially. And we're going to see examples of this as well. Episodic memory is an interesting one, right? So the back and forth interactions that you have with AI agents, that's a form of episodic memory, right? Especially when you add a timestamp to it. So it means that I can retrieve this aspect of memory using some form of maybe time-based retrieval query or something, right? Or it can also mean that this memory component or memory unit has a form of a subject to it. So summarization is a form of episodic memory. So summarization is a context engineering technique. It's when you have this context window, the context windows are bounded by token length, and so there's a context window limit. So whenever you're approaching the context window threshold, typically a technique is to summarize the existing content within the context window, and then pass that into a clean context window, and you just have the summary then, and you just carry on the conversation. Now, you would notice a lot of Cursor does this, because on the interface, you can see the percentage of your context window utilization. And in MemoRizz, the library that I created, we actually calculate this in every iteration as well. Because it's useful for both the human, and it's also useful for the agent as well. Because agents you want to be able to allow them to summarize their own context when doing execution, so you don't have context bloat, essentially. So within MemoRizz, the library, the agents can actually summarize their context as well, especially when you run them in deep research mode. So then we move on to semantic. Semantic, essentially, types of semantic memory are knowledge bases, or entity memory, or personal memory. So knowledge bases is essentially information that you have about the world that is stored in an external store. So for those of you that have implemented retrieval augmented generation or RAG pipelines, you would have used a form of knowledge base to ground the response of the LLM in some form of relevant data. That's an example of semantic memory. Entity memory, basically when agents interact with other entities within the environments that they execute in, you can store that information in a memory store. So for example, if I have an AI agent gaming is a good example for this. So imagine you have a character in a game and they interact with different entities in the game. You can store the information in your entity memory store and update it as your agent interacts with the same character over time. Humans do this all the time. So we have information of other people within our brain and their characteristics. So I've already explained shared memory, and I've explained most of the different forms of LLM context window and different forms of memory. So allow me to do something weird, which is just skip through all of this, because the animation order is not, I could have just closed this and skipped the slides. The animation order is not right. So now we can go into memory engineering. Now this is a part where I would like us to, if we can, discuss. If we can discuss if the things I'm saying to you sound more like context engineering, or does it sound like, do we need a new discipline to define the work that we're doing? So very quickly, I work with a lot of AI teams, and I've seen the things folks are building, and I've seen how they are optimizing them. And context engineering is one of the tasks that I see a lot of engineers doing. But then to improve the latency of your retrieval pipelines, you're going into things that look like search optimization, or if you're a database engineer, right, you would know things like pre-filtering or post-filtering, or you're just modifying the query just to improve the latency, because eventually we want these AI agents to work in real time and in production environment. So you're going to look at things like quantization of your embedding models and making sure you're using quantized indexes. So a lot of the work I saw a lot of engineers doing were around more memory type activities. In fact, a very large company, recruiting company, they have a specific AI memory team. How many people use Cursor here? That's good, a lot of people. I don't know if it's still the case, but at some point this year, there was only one person responsible for making sure Cursor is able to retain, recall, and reuse information. And that person on LinkedIn defines himself as a memory engineer. So again, still early days. It was early days last year. We're still getting to the point where people are beginning to understand the job to be done. I already defined what memory engineering was earlier, but I'll do it again. So memory engineering is the scaffolding that we have to write to move information from the components of agent memory, which is this external memory store that could be a database or a file system. It could be the LLM context window and the parametric memory within the LLM itself. So memory engineering is all the harness and scaffolding that we use to move data, which I call memories, between these components. And there's going to be a lot more content coming out on memory engineering. And I like talking about memory engineering because it's an area of agent engineering that feels like everyone can participate in, right? So you can have one engineer at Cursor, or like myself, building these libraries and frameworks, or you can have 100 engineers working on ChatGPT or on Claude to make memory work. But because it's not yet solved, it's a place where you can be creative, but also you can just constantly learn and participate in ideally getting us to what we can describe as AGI. So that's what memory engineering is. It's the job to be done. To me, it's the last job to be done, because once we solve memory, I think we're going to be on a very exponential path to an exponential trajectory to AGI. Once our agents are able to remember effectively well, and they're reliable, believable, and capable, it would give us a good path to AGI. So I want to touch on prompt engineering and context engineering and memory engineering. Now, again, I like to be interactive. I like to have conversations. So I'm going to ask a question, and I'm going to ask it now, and I'm going to ask it later on at the end. Does anyone put your hands up if you agree with the distinction between memory engineering and context engineering? Are we getting there? We're getting there. I see 3 people. OK, put your hands up if you agree with the distinction between prompt engineering and context engineering. More people. That's good. This is good. All right. So prompt engineering, I see it as, and I'll just go through this. So my aim is not to get everyone to put the hand up after I'm done. I would like to get a few more hands than 3. So let's go. Prompt engineering is very simple. In fact, I could skip this slide, actually. I'll just go straight to this one. Prompt engineering is a maximization technique, right? Because what we're trying to do is get more tokens into the context window to ensure that the LLM gave us the right answer in the right format. So we had things like few shot prompting, right? Because then what we did there was give the LLM examples of outputs that we expected, and we also gave it examples of inputs. And the more inputs and output you gave it, the more, essentially, the more it was able to adhere to whatever format you expected. So it's a maximization technique, right? There was this chain of thought approach, and there is in-context learning as well. But the key thing is here, we're front-loading cognition. So the LLMs, we gave them more data, more compute, and they grew a lot bigger, right? We increased the number of parameters within this LLM, and it reduced the amount of prompt engineering that we had to do to get what we wanted. But then we found out that even though we were increasing the context window of these LLMs, stuffing information in there, using that maximization approach didn't work. It didn't give you the, I guess, what we can loosely describe as this promised performance gain, because we had issues like needle in the haystack or lost in the middle problem, right? So the more information you gave this LLM, the harder it was for them to remember certain key information. So, and you go into things like context rot, you have context bloating, confusion, all of these key buzzwords. So context engineering and Anthropic define it best. Essentially, what context engineering is finding the configuration of the optimal tokens to put into the context window, right? It's not putting everything you can, it's just putting the right thing. Essentially, you're trying to get the most bang for your buck, right? So it's an optimization engineering. It's optimizing, right? So prompt engineering, maximization. Context engineering, optimization. Now, memory engineering, because we have these free components that we're working with within an agent, and we're trying to move information through these free components. We actually have to do a bit of optimization and maximization. So memory engineering is continuation, and it's continuation because what we're essentially doing is the maximization aspect will come into where you're taking things out of the context window. Sometimes you can augment this information, so you can enrich this information, so in the next iteration, you can actually have more, I guess, more information to play with, or more context to play with to get your desired output. But in the same aspect, it's optimizing because we have summarization technique from context engineering that you can store in your memory store as well. So you have to use some of this summarization aspect. It's optimization as well because we have to optimize the retrieval pipelines. We have to think about quantization. We have to do things like pre-filtering, post-filtering, optimizing all the queries that we're actually that we're using to retrieve information. So it's both optimization and maximization leading to continuation, because we want memory to persist and improve, and eventually our agents to learn and adapt over time. So that's why prompt engineering is maximization, context engineering is optimization, memory engineering is continuation. I think you guys would get the slides as part of the question. We need to use the mic.
Is it possible to put the slides in the Google Drive for the workshop? Because the font's really small.
Is it possible for?
Can you just drop the slides in the Google Drive for the workshop so we can follow along on the screen?
Yeah. So you want me to do that now?
Yeah, if you wouldn't mind.
Just say it. So where is the Google Drive for the workshop?
So the other thing is, you're going to share a link in.
Is it too small to see? Yeah. Okay. Apologies.
If you send it to me via Airplane.
Yeah. First thing I need to do is connect to the Wi-Fi.
Use AI native dev.
Do you have the password?
AI native dev.
Oh. Security.
Yeah, we've heard of it.
And I think it's connected. Okay, cool. And
AirDrop to me. I think I'm.
there we go.
Are these slides okay to go public?
I am a noob at this, so let's see.
You
There you go.
Yeah, if you want to share with me on Alan at Tesla.
Just go to
AirDrop
Oh, contact
whatever's
only.
easier.
Okay, how do I find someone on this? I don't usually use
Or
this.
if you want to share that, is that
Share the link?
Yeah.
Yeah, this is fine.
Or just hit my Alan.
Ah, yeah, let's go.
ALAN
ALAN.
at tessl.io.
Excellent.
That's
Me
me.
came up. There you go.
and I'll drop it in.
Drop in the thing.
I will drop the link in the Discord.
Okay, that's a good 5-minute break. Thanks a lot for mentioning that as well, the fellow that actually mentioned that. And that is my worry for the workshop. The screen might be too small to see all the cool logs and whatnot, but we'll try our best. Okay, very quickly, very quick question. Are you guys having fun? That's good. And got a question. Alan, we got to use the mic. Let's go. No, it's good. It's good.
Hello. Quick question. I know we're talking about memory engineering. The more I hear about it, it's part of a cost issue. But if costs aside, is that not just building or expanding upon the model itself? Like you're almost like training the model, but not. It's just outside of it.
Yeah. So.
Because obviously building a model is very expensive. Is this?
Yeah. So what you're saying is memory engineering just training the model, fine-tuning?
Yeah. I
Yeah.
guess. Because you could, all the memory here, you could take that data, right? And then
exactly. You can use
put it in the model itself.
Yeah.
Eventually.
So memory engineering is one thing is this space is still developing, and you're spot on, which is eventually where it's going to get to is continuous learning, right? We had this already in machine learning, so it's not new, right? Back in the day, I say back in the day, I'm not old, I'm actually quite young, I think. I'm in my 30s. Back in the day, we used to have these things called feature stores, right? And they allowed for online learning where you could solve issues like model drift, right? So we used to have this for traditional machine learning model. We're going to have that in LLM, right? In generative models very soon. They're large, and the latency is quite huge, and there's a lot of compute required to actually retrain them. But we are going to get there. Today, the memory engineering I'm presenting to you is actually half of the job to be done, because what we're doing is very simple. We have these three components of agent memory. We have the external memory, we have the context window of the LLM, and we have the parametric memory within the LLM itself. But we're not modifying the static parametric memory within this memory engineering scaffolding, right? But eventually, we are going to get there. And when I do this talk next year, we're going to be talking about that. You could fine tune now, actually, but it's just the time it takes, right? The amount of data you need. But one thing, Cursor put out a good blog last week that talk about that they're using the agent traces, and they're using that to fine-tune their embedded models, and they see improvements in the semantic search. So again, obviously they have loads of money to be able to do this, but we can't do this. Well, I can, but your average AI developer can't do this on a Jupyter notebook, per se. But we are going to get there. Good question.
The link is in the Discord.
Excellent. Okay, let's go. So prompt engineering it's words about, well, let me just recap. So we said prompt engineering is maximization, context engineering is optimization, memory engineering is both maximization and optimization leading to continuation. So prompt engineering was words about the world. And the reason why I have this here is when I was creating the slides and thinking about this topic more in depth, I was really thinking about how to distinguish the differences between these engineering disciplines, right? And sometimes simplicity is the best way to approach things. I do have an over 10,000 word essay that I'm writing, but this 3 lines probably summarize the 10,000 words essay, which is prompt engineering is words about the world, right? Context engineering is about word building. And then memory engineering is about word persistence and the continuity of this world that we're building for the LLM to understand. So prompt engineering is just about the words that we're using to describe the word. The description is key, because if you change a bit of the words, we found if you were to change certain words in your prompt, it changed the behavior of the LLMs and it changed the output. So the description aspect is key. Knowing what linguistic patterns will actually get you the right behavior from your LLM is part of this whole evaluation, LLM evaluation discipline as well. Then context engineering is about not just using the word, it's about building the context efficiently so your LLM could understand this world that you're building, this problem domain. Then memory engineering is the work that we are going to do to make sure that the LLM is, the world is persistent and it's constantly persistent through all the iterations. So let me ask the question again. How many of you agree with me on the distinction between context engineering and memory engineering? Put your hands up if you agree with me. Okay, we're increasing. That's good. We're making progress. Again, I fail if no one agrees with me. I also fail if you all agree with me. So I'm going to ask it a couple more times. People always used to ask me, Richmond, when does data become memory? And I have this line in the next slide. This line didn't start off here. It started off way here. But eventually, as I began to understand more and more, I moved it further, and I began to see the capabilities of the infrastructure that we have today. Let me explain. So there is this memory engineering lifecycle. If you read any white paper on sessions or memory or context engineering, they're going to talk about this lifecycle. And it's I don't want to say simple, but it's easy to understand, right? So we have data sources, external data sources. We're going to collect them, ingest them, clean them, do all the data science stuff we used to do back in the day. Then the next aspect of things that we tend to do is we create different representation of this data. And the most common one that we have within generative AI today is embeddings, vector embeddings. We take data, pass it through an embedding model, and we get the numerical representation of that data. And the numerical representation has captured the semantics of the data. So we have embeddings that you can couple with the data, and you can then ingest that into a database like Oracle AI database, where you'll be able to do things like semantic search, using vector search, or you can do hybrid search, which is a combination of vector search with any of the other search that we enable within a database. Then another aspect, and this is the part where we start to see why memory engineering is important. Another aspect is the organization of information. Data modeling is a topic I should have paid more attention to when I was at university, because it's important now. How you structure information is actually important to both the understanding of data and to the LLM itself. Organization of information improves the performance of an LLM if you actually think about it, right? So we'll talk more about this organization factor of the context window. But organization of information, which can be data modeling, the information that you put in your database, organization of information that you're putting in the context window as well. Anthropic's piece, which is titled Context Engineering, and I don't remember the rest of it, but type in Anthropic Context Engineering, they have a good image that shows the ideal organization of the context window, maybe for their models, and the piece that Google just put out last week called Context Engineering as well, Sessions and Memory, they also have like explanation of the ordering of items within a context window. The key thing here is organization is important. Retrieval. Retrieval is then in the pipeline as well. How do we get the information out of the database, right? Again, the two things, which is vector search is not all you need, right? Vector search is a good technique and you should use it, but you shouldn't rely on it or think it's the sole way of retrieving information. I know there was the rave about vector search and vector databases, but we quickly realized that we needed robust retrieval mechanisms to make our AI agents and the LLM accurate, which essentially means reduce hallucination, essentially. And one thing is becoming very obvious, but another thing that happened this year and late last year was, especially with coding assistants, using tools like searching through files using grep or using bash command to just search for keywords within certain file became almost seen as a replacement for doing forms of database retrieval. But again, the best one, I don't want to say the best, but one of the companies in the front line of coding assistants, they put out a blog last week saying, hey, we're not just using searching through files, right, using typical search tools. We're actually using semantic search enabled by database as well. And this and semantic search and using a combination of both performs better. Retrieval is a key aspect. Then you have this part over here, serialization, whatever we want to call it. But the key thing here is we're taking the information from the context window and putting it back into our data store, essentially to repeat this loop here again. But that's the key thing. This is like the memory engineering lifecycle. You call it a memory lifecycle, but this is what I'm seeing. Then eventually we're going to put the whole aspect of retraining the model, the LLM itself, or even retraining the embedded model within this lifecycle as well. I'm going to update the slides in a few months. So the question was, Richmond, when does data become memory? Because you've used the word memory a lot, right? That's what a lot of people used to say earlier on when I used to talk about this topic, back when it wasn't accepted propaganda like it is today. People used to say, Richmond, yeah, when does data become memory? Or what's the difference between data and memory? Spoiler alert, memory is data. And the point where we start to see data becoming memory is usually when you see the information being transformed and represented in a different format. That's when you begin the understanding of it as memory. It helps when you're building an AI agent if you think about information as something that is to be remembered, but also something that is meant to be forgotten. It helps when you're building these agentic systems. Okay, so prompt engineering, maximization, context engineering, optimization, memory engineering, continuation. I am not going to say those paragraphs there. I can't remember them, and they're too extensive. Okay, so this is the journey we're on, right? Prompt engineering, context engineering, memory engineering. We've mentioned a bunch of keywords, and I hope have hit on those keywords. So if you look at them when you have the slides, they'll become very obvious to you. Now we can go into the workshop in code, and that took about 45 minutes to explain. So the key thing is not, what I'm trying to get across to you today is not to give you a solved solution, but to give you essentially the scaffolding of thinking, a scaffolding for thinking about what is going to be one of the most relevant aspects of agent engineering or AI engineering or software engineering within the next 6 to 1 year. 6 months to 1 year. And it's 6 months to 1 year because I'm hoping everyone is doing their job right, because we need to solve memory very quickly. And I think within the next year, we'll have very, very solid solution to agent memory. So you can call me, when I did a talk about agent memory, the first one I did, I think it was earlier this year. It was in Greece, and I tried to make it cool. And I told a story about Prometheus. Does anyone know the Greek mythology of Prometheus? Put your hands up if you know. That's a lot of people. That's crazy. So yeah, I was in Greece. I was like, oh yeah, let me be cool and talk about Greek mythology. Prometheus, obviously, Prometheus essentially gave man fire, and he got punished for that for eternity, I think. Correct me if I'm wrong. But he got punished for giving man fire, and fire in the sense of intelligence to be able to build tools and obviously flourish. I'm not saying I'm Prometheus, but anyway, so we're going to go into the workshop and code, and hopefully I don't get punished for eternity. That's weird. We're going to talk about MemoRizz. Again, the name is a joke. It's not like the official name. We're going to talk about the agent stack. We're going to talk about keywords like memory core and memory layer, or memory provider as well. So to find the code, and this is small, I apologize, but I hope you have the slides. You can type in MemoRizz GitHub on Google, and I hope the library comes up as the first link. When you go into this repo, you'll be able to go into the examples folder, and you're going to be able to see a single agent folder within the examples folder, and then you guys can click on the local one and go through the process of building an agent augmented with memory. I'll take a pause there. Do we have any questions?
Should we grab a quick coffee? And I also need to mention lunch is at 12 over at the 52A, just like in case your tummies are rumbling, that's where lunch will be at 12. But if you want to grab a coffee while we're doing this,
Yeah, dude, I don't drink coffee, but I have water, so.
you're good.
Yeah.
There's
The
juice,
smell of coffee
there's
makes me want
juice
to
as
throw up.
But yeah, dive in. And if anyone has any difficulty getting hold of the slides or cloning the repo or anything like that, just grab me or Richard and we can point you in the right direction.
Excellent. So
Thanks.
I'll go over some propaganda. I'm joking. I'll go over some of the slides, and then we can get an understanding of the repo, and I'll go through some of the code as well. Okay, so the key thing here is we're all there to learn. So you can ask me questions. If you disagree with me, say you disagree with me. I don't mind. I won't cry. But you can also reach out to me on LinkedIn. I'm responsive sometimes, and we can have a good chat of agent memory and memory engineering. And if you reach out to me on LinkedIn and I ignore you, it's because I'm probably doing a talk like this. I'm preparing for it as well, which usually takes a couple of weeks. But do reach out on LinkedIn. So this is, again, small to see. I apologize. But if you have the slides in front of you, you can go for it. Let's talk about the agent stack. So there are a couple components within agent memory that are just staple, right? And you have a bunch of people that operate within the layers of agent stack. The key, I'm not going to go through each one, but I'll just talk about the key one. So we have the communication and protocol layer, right? This is your MCPs, A2A. What's the one from IBM called? Is it called ACP? I think so. I'm not sure.
What slide number are you on?
I'm on slide number 46. Oh, you guys are on the slides. Wow. Okay. There was another question. No, my inner thoughts. Okay, so we have the communication and protocol layer, right? This is where your protocols, A2A, MCP actually reside within. But one thing we're doing in Oracle is we saw the emergence of loads of different frameworks. And the engineering team at Oracle actually looked at a key thing, which is how can we standardize agents across all of this framework so that you can take an agent built in like CrewAI and move it, port it over to LangGraph. The best way that they describe this is the Onyx framework, which we used back in the day to use the same model built in PyTorch. You could use that same model using the Onyx model within TensorFlow once upon a time. But again, I joined Oracle 2 weeks ago, and I could see that there was this amazing engineering effort to try to standardize and really bring agent engineering to the forefront of AI developers. Hence why I'm here, hence why I'm at Oracle. And the open agent spec is very interesting to me because I knew we had to, I've worked in other database companies, and I knew that the way we solve a lot of the different attempts at making agents work in production is to think about how we can standardize this. So Anthropic did it well with MCP, and Oracle, they're trying to figure out how to standardize the porting of agents across frameworks. So that's the communication and protocol layer. You can check it out, the open agent spec. There's a paper that we wrote, and you can check it out there. So there is this orchestration layer, right? That is where your frameworks and library live. LangGraph, you have folks like Haystack that operate within this layer as well. Then there's the reasoning layer, which is the LLM. This is the model provider. This is where they live. Then you have the memory layer. So I'm going to explain the memory layer. It sounds weird, but the memory layer is the scaffolding that we do in memory engineering, but a bunch of very helpful engineers have abstracted away a lot of this common techniques and process. So example of that, like I saw a lot of hands up, is Mem0, right? Mem0 is a memory management layer. LangMem, check it out, from the team at LangChain, that's a memory management layer. Cogni is another one, MemGPT is another one, and a couple of them are popping up. There's one that I saw that raised a crazy amount, and it's called super memory, right? Did anyone hear about super memory? Hands up if you did. Some hands up, just one. But yeah, more are popping up. I think we're going to see more from maybe the model providers pop up as we go through the year as well. Then the memory core is different from the memory layer. So the memory core essentially is the database itself. It's the store where the information is stored, right? It gives you all the retrieval mechanisms for really pulling information out. And what memory layers typically do is they help you engineer all of the different memory types that we've spoken about, the way that the data is modeled and the way data is retrieved as well. They abstract this away from you. So ZEP is a popular one as well. Has anyone heard about ZEP? Hands up if you've heard about ZEP. Nice. They're very big on the knowledge graph space. So those tools abstract this complexity of understanding the memory types and understanding how to retrieve information. They abstract that so that you guys can get to production very quickly, which is obviously a good way to go. And it's the same thing I'm trying to do with MemoRizz. MemoRizz, like I said at the beginning of this, it was a way to prove a point as to where this field is going in terms of the work that we have to do as AI engineers or AI memory engineers. And you should not use it in production, actually. I actually have that in the README, don't use in production. But it's a learning tool, so you can look through the code and learn from it. OK, so that is the difference between memory layer, a bunch of engineering, and programmatic code to actually move information and model data. Then you have the memory core, which is your database that will give you all the retrieval methods and storage and all the compute you need. Then there's the obvious infrastructure layer as well, which is the actual compute and inference and all the good stuff. So that is the agent stack. I'm going to update this a bit. I feel like we can consolidate some of these layers as well. This is MemoRizz. You could type in MemoRizz at GitHub, or you could just go into the link on the next slide. Let's see. Oh, that was the last slide. You go to the link on the previous slide, this slide over here, go into the examples and into the local folder, and you'll be able to go through the notebook there. OK. Let's go into some code, and it's going to be small. Can you guys see this? Let's see. Let's try this. Tell me you guys can see this. No. OK, just a little bit.
There's no local folder.
There's no what?
No local folder in examples, at least not.
Let me verify that.
I see deep research.
Yeah.
Single agent.
There's a single agent, and there's a mem agent _ local. There you go. So you can just run that, and what that would do is, you guys can't see the code. A part of me wants to do something, which is bring you guys all up to the front and watch me execute this. And I think you'll be able to see it. Yeah? So those of you who are very interested, you can come up to the front. Are there pillows? I'm joking. But we can just sit down here or just stand here and just watch me. It's going to be fun.
You just bring your chairs in front.
Nah, you need to sit on the floor. You gotta make it cozy, man. No, I'm joking. Bring your chairs to the front. That was a better suggestion than I had. I was going for pillows. Okay, cool. Don't be shy, guys. This is gonna be the best workshop. All right, let's go. So if you run through this notebook, I'm going to show you two notebooks, and we could go through it very quickly. If you go through this notebook, you're actually going to install the Oracle AI database on your local, and you're able to run through the step. So you can install this using Docker, and I've kept as much instruction as possible to make sure this is a seamless, I hate using the word seamless because ChatGPT loves that word, but this is a seamless experience for you. Feel free to go to the link. The key thing is, and let me just start this. We could start with the first. So again, there are two ways you can do this. Within the MemoRizz library, there's a CLI. So when you actually pip install the package, pip install MemoRizz, you actually get a CLI with it. And you can use a CLI within your own setup, your own environment. So let's start with this. So you're going to pip install. Let me increase this again until it gets uncomfortable. OK, we're going to install pip install MemoRizz, and we're going to also install Oracle DB. That's going to be our memory core. Then we're going to use OpenAI as well. I do have some examples that show how to use some of the models from Hugging Face with the MemoRizz library. So we're going to start running this, and there's nothing exciting happening here. We're just running a bunch of stuff. So that's good. So part one of this notebook is just the setting up of Oracle AI database. And the key thing we're doing here is we're just going to I have a Docker container running. Let me clear all these outputs actually so we can, yeah. So this is what a CLI command is going to look like. So MemoRizz install Oracle. I'm going to add more memory providers as I'm permitted to. Then you would just run maybe, let's see. When you run this very quickly, if you don't have Docker running, it's going to tell you Docker is not running. But it will also just install the Oracle image for Oracle AI database image, which should take around 1 gigabyte within your local memory. There is a full version of the Oracle AI database that takes around 9 gigabytes, but it takes longer to install. If you would like to install the full one, you just do this, -- full. And that will install the full version for Oracle AI database. But the light one is enough. So once you actually run this command in the output, you're going to see a bunch of information for your environment variables. Question?
So you mentioned 9 gigabytes for the database size. Is that, you found that to be plenty for all the agent work you've been doing, or does it need to be expanded out much larger or anything like that?
So the local installation, the light version, is just for you to get started. It's not meant to be used particularly in production. Again, the thing about Oracle database is the enterprise-grade security. We work with a lot of Fortune 500 company, and the full one has a bunch of these enterprise-grade securities, right? But to get started quickly, we created a light version. So you could just install it, less time to download. But check out Oracle Cloud if you actually have production workload, and you can just follow the same steps. That's why within the same notebook, there's a mem agent remote where you just put in your connection details, and it just connects to Oracle Cloud database. Any questions?
So is 9 gigabytes on the hard drive or just like in the Docker? You said
Pardon?
9 gigabytes, was that?
9 gigabytes of memory.
Pardon?
9 gigs of memory.
9 gigs of memory for the full one. Around 9 gigs.
Oh,
Yeah,
but
I
for
think
this workshop, it's not going to take up that much.
It's not going to take
Okay.
up that much. Yeah. It's not.
Good clarification.
OK, so when you actually run this, you're going to have your admin password in the output. And what you can do is just get that in there. We need to get that into your environment. And that's what this cell does. Nothing special is happening there. This just allows us to connect to the Oracle database. So the next thing we're going to do is we've installed the Oracle AI database within our local machine. Now we need to set it up. And what we mean by setting it up is creating a MemoRizz user, creating all the tables and vector indexes that we need. And again, the CLI solves this. MemoRizz set up Oracle, and it's going to do a bunch of stuff. It's going to kill any sessions if they already exist and start a new one. And you can see here, it's just executing a bunch of statements and creating a bunch of indexes, and it's done. Very quick. And if you don't want to go through option 1, there is a manual installation where I take you through all the steps, where you just start from scratch. And I think I put a link to where you can get the Docker image from somewhere. But we're not going through option 1. We're going through option 1, we're not going through option 2. So now that we have Oracle AI database in our local machine, what we can do is next is start to build our mem agent. And I call agents built with MemoRizz, I call them mem agent. Can anyone guess why? Memory agent, mem agent. I'm bad with names. Whenever I write code, the naming of my variable gets worse. OK, so this is just for login. This is for environment variables. It's going to be so weird switching my screen to put in my environment variables, but I'll just delete them after. OK, so we're going to be using OpenAI for this. So you need to actually have an OpenAI API key. Can we switch this screen so I can get my environment variables put in? Nice. I don't trust you guys. Exactly. Pardon? Okay, so we can switch back. Nice. Okay, so here we go. So one thing we're going to do is we're going to create Oracle configuration, and that's just so we can create what I call a memory provider, and Oracle is going to be our memory provider in this particular instance. And Oracle AI database, that's the memory core. So this memory provider is a bunch of is a bunch of abstracted code for how to create indexes and how to do the retrieval, and the memory core is Oracle AI database. So we have an Oracle AI database, we have the Oracle provider initialized, and you're gonna get a bunch of information in the logs as to what's happened. The key thing is you wanna see this when you do the notebook and no errors. All right, so this is the fun part. We can just straight away build an agent. Actually, I went too quick to do that. So let me explain this code. Within MemoRizz, right here, apologize for the cough. Within MemoRizz, we actually have builder module, where we have this abstracted class called memAgentBuilder, and that will just build a very simple agent for you. So we're gonna initialize something called, again, the name is bad. The name of this agent is Agent Builder Made, bad naming. But the key thing is we're creating an agent using the memAgentBuilder. We're gonna set it with its core identity. Using the with underscore instruction, we can just give it like a system prompt, essentially, right? Then the infrastructure of it, we're gonna set it with the memory provider that we set earlier on, which is Oracle, and then we're gonna give it a bunch of LLM configuration. So MemoRizz will recognize embedded models from OpenAI, but this is the LLM. So we also recognize LLMs from OpenAI as well, and the Hugging Face as well. So you need your OpenAI key, and you just call the build method, and that's done. So one thing you're gonna notice is this. There's a bunch of logs, but I'm already adding tools to the agent when you actually initialize it. And the reason why I'm doing this, you can see the tools here. I'm just gonna scroll in. And you can look, all of this code is open source, so you can see what is being done and how I'm doing it. The first tool is context window stats tool. Like I mentioned earlier in this talk, the agent, every agent we initialize actually has awareness of the context window length, so it can then auto-summarize, right? So it doesn't fall into the context bloat or exceed the context threshold. Cursor does this automatically, and they have the GPT codex actually does this as well. They've got like a little meter that you can see. Then there's another there's another tool, list summary registry tool. Just whenever we do the auto summarization, I want to be able to see existing summaries and actually fetch the summary, and also look up entities and insert entities, because this agent is going to interact with other entities, whether within the context I provided or the context it has when it's interacting with its environment. So automatically, it can actually, it actually stores entities it interacts with in its memory store. This library is a bit opinionated, but very quickly, we've initialized an agent with this different memory, conversational memory, long-term memory, persona. So we've initialized this agent with those type of memory, and it's been built successfully. And I can store everything in Oracle AI database. If you're watching this back on YouTube, the coughing must be so annoying. I hope this is edited somehow. Okay, so when you save it, we actually store and again, MemoRizz is my personal project. It's not an official product from Oracle. So just wanted to put a disclaimer out there. When you actually store this, we actually store the agent information in the database, and we have a memory ID we have a single memory ID for a bunch of agents. And the reason why we store it is because we want to be able to load and reuse agents within different environments just by pulling in information from the database that's been stored to actually then load it within another environment. So we're going to start building an agent. So we're going to build this agent builder. We've already built our agent. We've saved our agent, and it's called Agent Builder Made. Terrible name. We're just going to run it, and I'm just going to say hello. My name is Alice. My name is not Alice. My name is Richmond. But for this example, my name is Alice, and I love hiking in the mountains. and we're gonna see its response. And you can see very quickly, we're just gonna go through the outputs actually, very quickly, and don't worry about the speed. There is no quantization, and I'm not trying to optimize for latency here. And I should have probably kept streaming as well, but very quickly, we're gonna go through the logs. What we can see here is, first, we're loading information, but there's zero conversation within previous interactions, so that we've loaded zero conversational memory. And you can see that we're able to see what's in the context window. So we've used 513 tokens with the existing 128 length of the context window. But now what we've now done is we're executing the tool and we're inserting an entity in the entity memory named Alice. The entity type is a person and it has the attributes favorite memory, hike in the mountains. And it's doing this automatically because it has the entity memory. Now our agent is going to remember Alice and is going to be able to update its information about Alice. Now we're executing this tool lookup. We're looking at we're retrieving the memory and we're passing it back into the context window. That's why you see this increase in the context window length. But very quickly, the agent says, "Hello, Alice. It's great to meet you. I've noted that you love hiking in the mountains. If there is anything specific you would like to talk about, or yeah, blah, blah, blah." But you get the point, right? Right out of the box, you have an agent that can remember a certain entity that has interacted with within its execution and stores it within a dedicated memory store. But also you have an agent that can just use tools. And these tools are also, I never mentioned, but these tools are stored in a database, right? The JSON schema for these tools are stored in a database, and the agent can just use the right tools it requires using some form of vector search operation. The way I do it is I take the doc string of the tools, I create an embedding for it, I store it into the database. For every query, I look at the vector similarity, then I'm able to select just the tools I need rather than giving it all the tools I have. Does that make sense? It makes it easier so you don't bloat the context.
So,
That's right, it's coming.
okay. So for this example, obviously, like you're passing the memory, context as plain text. I could imagine a more complex example where you want it to be structured, right? Like, have you tested that out? Do you support that in the demo library? Like, what's sort of the differentiation here?
Yeah, so your question is, I'm sending all the information into the LLM as text, right? Is how you...
Yeah, and like, why would you do that rather than just saying, like, name Alice?
Dave Alice.
Like, name Alice,
Name Alice.
right? Rather than saying, my name is Alice, I'm an LLM.
Oh, the reason why I'm saying, hello, my name is Alice, is just the input prompt, right? It's just an example of how you interact with LLM through text, right? Am I getting the question wrong here?
I was thinking more like, if you're building this sort of tool to create memory for the agents, right?
Yeah.
Like, I can imagine a world where you don't want to put all of the memory as plain
Yeah,
text,
so
right?
you want to create like an agent that is barebone and just give it the memory it needs, the memory types it needs. You can do that here. I'm just showing one that builds everything. I'm building MemoRizz for fun, obviously, not production use, but I'm building it for every memory type to be a standalone. So you would use a tool like LangGraph, and you would then use entity memory from MemoRizz and only use that particular memory, right? So you just add it as a tool for the LangGraph agent to use.
Okay, so just for demo purposes.
Yeah. Sorry, it took a while for me to grok that. Okay, let's go. So we went over this, speaking to the agent is telling us stuff, and this is, I'm trying to demonstrate conversational memory, but I've also demonstrated entity memory as well. So let's just see, I'm gonna ask it what was my name again. It should be able to remember my name. Okay, cool. Your name is Alice. So we're running the same agent and it remembers our name. So I've not done any extensive scaffolding for it to remember my name or for it to, you can see it did like an entity memory lookup, right? So again, this is all of this stuff is doing behind the scene without having without having me having to write this extensive code. You can see loaded previous conversation entries. Before it loaded 0, now it's loaded 2 because we've interacted with it. That's conversational memory, that's entity memory, that's tool memory, and now you have conversational memory, and that's the response. Okay, let's look at persona. We spoke about persona. Personality, essentially, is what it stands for. We have this, MemoRizz has the aspect of different long-term memory types that we went through in the slides. So we're going to look at how we can get persona in. So this is a prompt, or this is just a text for a persona description. And we're going to make our agent a bit emo-like. And the reason why I'm doing this is not me, this is not my example, but was it this year or last year? Either this year or last year, an April Fool jokes from OpenAI was to create an emo GPT. So there was an emo GPT called Monday within your ChatGPT interface, and you could interact with it, and it gave you emo-like answers, like sad, sarcastic answers. But one thing you could do is you can ask it to give you its system prompt, and this is it. It actually gave you the system prompt when you asked it. So I just copied and pasted it. It was called Monday, and I think it was an April Fool's joke. Okay, so I just took it. We're going to make our agent a bit more sarcastic, and because I'm bad with names, I named it Sunny. Obviously, contradictory. But we're going to create, within MemoRizz, you can create a persona object, and we're just going to pass that into the variable persona. And then we're going to create a new agent. It's called sarcastic agent, which is better than the other agent's name. With the instruction, your sarcastic and cynical assistant, we're going to give it a persona. You can see with persona, pass the persona in, use the same memory provider that we already configured, and the LLM configuration as well. We build it, great. And this is a brand new agent. And it gets all the tools that it needs. And you can see it's been created, and we can store it in our database. Now it's going to be persisted. Now it's going to be persisted in the database. And we can ask it, what is your name? And its name is Sunny. We specify that in a persona, and it's going to remember its name. So again, but you can tell it's sticking to its persona because the age-old question that haunts humanity, what's in a name? You can call me Sunny. He answers a question, but it sticks to the persona we gave it, which is it's sarcastic. So it's a bit of a personality that we're able to give our agents. Now, obviously, you don't want to be using this in your FAQ agents for your for whatever companies you work in. But again, I'm going to tell it, hey, I am Alice. Nice to meet you, just to show that we still have this conversational memory going on. And I'm going to ask it, what was my name? And it says, oh, slipping already. Don't worry, your secret is safe with me. You're Alice. It remembers, it's sarcastic, has conversational memory, has entity memory. Now it has persona memory. Right? Are you guys following this? Nice. Okay, we're going to create another persona. You can tell this example is very long. So I'm going to then take a persona, but every agent built with MemoRizz, you can actually set a persona. So we have this agent builder made. I'm going to change the name after this session. Agent builder made agent, and we just call the set persona method and pass in this persona object that is called Moody, and this is meant to be a Moody assistant. So I've already run this, and it's updated the existing agent. There's a bit of error here, but that's fine. It should still work. We're going to ask it, what is your name? Wow, then it just died. And it says, I'm Moody, because we've set the persona to Moody. It remembers, and it's going to ask, now it's taking on this persona. Though I might have a bit of mood about it sometimes, what can I help you with today? So that's an example of, again, persona memory. Let's talk about toolbox memory. One of the key things about LLMs is they have this emergent abilities to actually call the right tools at the right time. So we're going to give the agent a couple of tools. So one of the tools, well, we're going to give it one tool. We're going to create a weather agent. We're going to create a function called getWeather. We're going to give it a string, a doc string that describes the function. And then we're going to just use a simple request to this particular API endpoint. And we're going to pass in the latitude and longitude. And that will give us the weather, particularly the degree, the temperature within a certain location. So we're going to build a weather agent, right? You guys can see the pattern here. We're going to give it the instruction, but now we're going to add it with tool get weather. So we're passing a tool into it. And we obviously we have a memory provider and we have the with LLM. And what happens is now this agent has access to this tool because when we save it, we store a JSON schema of the tool in the database attached to the agent, right? We have a referential ID of the agent ID attached to where we've stored the tool, JSON schema. So I'm gonna ask you, what's the weather like in New York? This is actually sick, and I'll tell you why this is sick. I've done this example so many times this year, and this is the first time I am actually doing it in New York. So it's actually, I just realized that, that's just mind blowing. I'm based in the UK, live in London. All right, so, and you can see it works. So the weather is 7.3 degrees. Excuse me, can you go outside and check if that's correct? It's correct. I'm joking. Okay, so yeah, here we can see that it's able to use the tool. It has awareness of the tool and it's giving us this degrees and the right weather. And I'm just gonna run it again. Is it warmer in Los Angeles? And you can see I'm not even passing in, oh, I am passing in the longitude and latitude. I shouldn't even do that. I don't need to do that. This agent is smart. Well, just in case it fails, you can see it says, yes, it's warmer in Los Angeles, 11.8, compared to New York. Let's see. If you don't pass in the coordinates, actually, you will still get this right because it has conversational memory. Pardon?
It's using OpenAI, you said?
Yeah, we already used the LLM, its configuration is using OpenAI, but you can change it to Hugging Face if you want. I have an example that shows you how to do that. But the actual weather information is using, what's the name of this endpoint I'm using? Open Meteo. Yeah. Okay, cool.
About workflows, which are very common. How would you suggest memory works with like a series of tools or a tool and an agent, LLM pool, and then a few other tools?
You're asking about workflow memory, right?
Yeah.
So one thing that is actually happening that you can't see is the execution is being stored in its workflow memory, right? This agent in the database, we're actually storing within the workflow table, we're storing rows of the execution. So it actually has information of the workflow that has been executed. So I search for this particular tool, using these parameters, this was the result, and the outcome was a success.
And if I want to pre-bake certain workflows to this entire thing, right? How would I engineer the memory so it would know to go through a certain workflow when you're being asked, I don't know, something about the weather. Let's say, give me the weather in the US and then I want to do New York and then whatever, Los Angeles and Florida.
So if I understand your question correctly, how do you engineer the agent to be able to run multiple queries?
More than that, right? Like when I ask them, like the agent, hey, I just need the weather in New York, the weather in the US. I want the agent to return specifically New York, LA, and Miami, right? Like, and it's specific 3 calls to the weather app and maybe just like some comparison in between or something like that. How would you? But I wanted to answer that automatically when I ask the weather about, the weather in the US.
I think I'm understanding your question.
So similar to the way that you would do it in NA10, right? Like in NA10, you would go and build like an ETL sort of graph around it, right? Can we do that with just memory, saying like, hey?
You can do that with just code. Right, you can actually implement the execution step, right? NA10 is essentially just code in a sense, but yeah, you could do that with memory, you could do that with code. And I apologize, I'm not understanding this question correctly. So I'm gonna, what's your name? Oro. I'm gonna talk to you after this to make sure that we can talk and I understand what you're answering. If I don't, you can come to the UK and find me. Okay, so let's talk about semantic cache and just watching time because I'm in between you and lunch. I'm joking, I'm just hungry. But okay, so let's go. In this, we're just going to look at semantic cache. I've already explained what semantic cache here is, and we've already built different agents multiple times. But the key thing I'm doing right here is every agent that has been built so far has an aspect of semantic cache. I've not just told you. So one thing, and the way you can see that is, let me just make sure. Yeah, there we go. This is the semantic cache section. And one thing we can just see that is, I'm going to ask it, again, a question. The time taken is 1.4 seconds. And I remove this output that shows when it has a cache hit. I'm going to ask it the same question, just to test this again. Let me see. The output of a semantic cache hit doesn't show, which is terrible. So that doesn't help. I apologize for that. One thing I'm going to be able to do is we're going to enable semantic cache within this agent now. And when I ask it, this cell below, what's the capital of France? We're just going to calculate the time it takes. Right? So it says the capital of France is Paris. That's great. We're going to ask it again. What's the capital of France? It takes a shorter time because it's returning a cache response. Right? That shows semantic cache. It doesn't show it well, but there's another example. There is no cache hit here. If I ask it, tell me France capital in small caps. Even though it's the same agent, there is no cache hit, and it's giving us the same, a different answer, even though the same answer as before is Paris. What I'm going to do is tell me the France capital in small caps. Tell me what's another word for small? What's a synonym for small? Tiny in tiny caps. What other options did people?
Lowercase.
Minuscule, lowercase. Yeah, lowercase is more developer aligned. Let's see, lowercase caps. Okay, see, returning cache response. Because lowercase and small, again, very semantically similar, we'd have to go to the LLM, it takes a shorter time, and we don't pay OpenAI. Do you have a question?
What type of cache are you using?
I'm using Oracle AI database as a, yeah. It's obviously not the most optimal, but just showing the example. We have another cache feature called True Cache. You can check it, Oracle True Cache. But here is just showing how you can use your database as that memory core.
So this is not using AI or OpenAI?
No, so this specific call didn't have to go to OpenAI because we already stored the response. We stored the previous query when we had it as small, right, in the database, and we generated an embedding of this query in the database when we made it when it was small. So when we changed it to lowercase, what we did was just vector search, right? We did a vector distance calculation, and this query and the previous query are semantically similar, and then I have a threshold score, which means if it's within a certain range, let's say 0.8 to 1, which represents how similar it is, just use the stored response from the previous execution rather than going to the OpenAI to get me the information, because it's going to be the same information brought back.
But don't you need OpenAI to determine their semantics?
You need OpenAI for the first iteration, right? For the first execution, right? You need to actually go get the LLM response.
Right.
But for anything else,
No, but once you change it to lowercase,
yeah, once I change to lowercase, you
how
don't
does
need.
it know, how does it know it's semantically similar without
So-
going to OpenAI?
No, we don't go to, well, technically we do go to OpenAI because we have to generate the embeddings.
Okay.
But we generate the embeddings using OpenAI,
Okay.
right? Yeah, is that what you're asking?
Yeah.
Yeah,
So
we
you're
go,
still using you're not bypassing OpenAI in this case.
I'm not bypassing OpenAI. I'm generating embeddings using OpenAI, but I'm not going to the LLM. I'm not going to GPT,
Got it.
right? So I guess that should be very clear as well. I should make that very clear next time. I am generating embeddings, but I am not making an inference call.
Doesn't this introduce security concerns for multi-tenant applications?
Yeah, it does. So you definitely have to, I'm saying this MemoRizz does, right? The library MemoRizz does. That's what I mean. Because, hey, don't use this in production. This is me learning, but there are robust product features that we offer. Like I mentioned, we have Oracle True Cache, which has all of the security, enterprise-grade security standards you expect. But don't use this MemoRizz library because it doesn't have all of that in the library. Okay, so last one I want to show is summarization, and we'll be right on time. Let's skip summarization. I apologize. Let's skip summarization so I can show you deep research, right? Just very quick. Summarization is you take the long context, you summarize it, store it somewhere, and you can use the summarization to update the persona as well. Apologies for not going through it. I just wanted to go through this deep research example. So I am not gonna, damn it, I have to retake the screen so I can open my, pass in my keys, and I'll let you know when we are good to get that in there. Thank you. Let's go. So we need the OpenAI key and one more key before we put it back in. I'm gonna be using Tavily for my search. So deep research, obviously, we wanna be searching different URL. We're good to go. All right, so kept in all the keys. I'm using OpenAI as the LLM. I'm using Tavily. Have you guys heard of Tavily? Yeah. Excellent. So I'm going to be using Tavily for the internet search, and we're just going to be actually creating all the steps we did before. But here you can switch the model to a Hugging Face model if you want, and you can also switch the embedded model as well to a Hugging Face embedded model. You can switch the model later to a Hugging Face model. So if you want to run this locally, you can just use this. You can use the Hugging Face LLM config and just pass that into the provider itself. I will show where you can do that later. The key thing is we have this Tavily provider, which built into MemoRizz, it gives us internet access. And you need that for deep research, because deep research is basically, you have a prompt that maybe initializes an agent that can do a bunch of extensive analysis, and one of that could be going into a link, right? And then you want to go into another link that may be citation within the other link and embed as deep as you want to go. But I have some configuration to just set max results from the search that we do. I'm using Tavily to do web crawling and also searching the internet as well. I have this boiler function called build agent, and we can create this deep research agent, specify Tavily as the internet provider, and create all the other configuration. And now is the part I actually want to get to, is what agents are we going to build? This is a multi-agent system, right? So we're going to have the root agent. The root agent is where the query comes in, and the query is going to be an Apple. This is a analyst agent. So we're going to use the build agent code that we wrote earlier. We're going to pass in the instruction that we want to give it, and we're going to give it more specific details about what we expect it to do. Assign tasks, monitor progress, and coordinate synthesis. Then we're going to have this delegate. We're going to have a root agent has delegate. So the way I call multi-agent, it will make sense later, is we have a root agent and we have delegates. And delegates are other agents that report to the root agent. So we have 3 delegates. So we have this financial delegate, market delegate, and a risk delegate. And they each have their own responsibility. And then we have a synthesis agent, which will essentially synthesize all the reports and get back to the user. So we save all of these agents in our database. We've done it in the previous notebook several times. You guys know it now. So we're just going to do this, and you can look at the logs. It's adding all the function and the tools. So all of these agents have their own tools, their own capabilities as well, and their own memory stores as well. Now we have this deep research orchestrator where we set the root agent to the root agent we specified, the delegates to the 3 delegates that we have over here, and the synthesis agent, such a difficult word. And we just pass in the synthesis agent. And then we run this, and I'm just going to pass in this query to provide a 3-year stock analysis for Apple, highlighting financial trends, market dynamics, and key risk. And that's the prompt, and we can put it in deep research mode. You can see the output, spoiler alert, but there's a bunch of logs just showing what's going on here. You can see it knows the number of delegates that it has, and it's analyzing the delegates' capability so it can give the right delegates the right queries to execute. And it might take a bit of time, but you can see here we're using Tavily to search the internet for a particular query, and we're looking at the results of that query. We're storing it, passing that into the context window of the LLM, saying, hey, here is the results from the search result, and it's just going to carry on the work At the end of this, when all the delegates are done, so the job of the root agent is to understand the query and then delegate it to the right agent, right? Parts of the query to the right agent. Then when the delegate agents are done, they go into the synthesis agent and say, hey, here is my work. The job of the synthesis agent is to compile all of this and give us the output. It's still running. Deep research can be extensive. But yeah, it's extensive because it's traversing through a bunch of links and conducting a bunch of searches. And the report looks something like this, just for the sake of time. You will get, oh, it's done. So yeah, so we just got the report. And it's just like an essay, essentially. Not an essay, a short essay covering all what we wanted. It's giving us all the right information, gone to the internet to search for this information. I was asking for the financial information of each quarters of Apple, and it's just gotten me the right information from internet search, deep research. Okay, was that fun? Yeah? Was it boring or was it fun? It was good. Yeah, you guys. Okay, I'm about to change it up. We will do maybe workflow agent next. All right, so I want to ask the question one last time. You guys can guess the question I'm going to ask, right? Do you guys agree with me on the clear distinction between context engineering and memory engineering? Put your hands up if you agree with me. Yes, that's good. I'll take that. I'll take that. That's better than what we started off with. We started off with 3. Now we're, I would say, maybe 15 or so. That's it, guys. That's all I got for you. Thank you for spending 2 hours with me.
Final questions before we leap out the room?
Final question right down there.
This might be a little orthogonal to some of the demo, but sorry, this might be a little bit more orthogonal to the demo and what you were presenting, but you mentioned episodic memory. What's a good use case for actually using episodic memory if you can synthesize all of the other information using the other different types of memory? I'm assuming that the orchestration and the actual methodology in which you arrived at the answer allows you to generalize the task, the agent. But I'm wondering how you use it.
How do I use episodic memory? So, sorry, say the last bit again.
What use cases?
What use cases would you use episodic memory, right? Generally, when you have assistants, I don't know if you were here at the beginning, but I identified 3 application mode. You were here at the beginning. So when you have an assistant agent, right, you want to use episodic memory. There are different types of episodic memory. Of course, you could generalize, you could summarize. That's what you mean by generalize, right? You could summarize a context window and store that somewhere. Is that what you mean?
Yeah, because if you use, again, I'm assuming, right? Like if you're using episodic memory, you're basically, because you're storing the entire process, you're effectively adding a lot more context that has to be loaded into the model, right? But if you synthesize it, I'm assuming that you can basically deliver that information faster without using some of that token context window.
So what do you mean by synthesize it, though?
I was hoping this would be a short question.
No, it's okay.
Yeah, I mean, I can just talk.
Yeah, we're just nerding out here. We're just gonna.
I worry that everyone's going to get restless.
We can carry on, and I still got to talk to Aura over there. So, we can turn off the mic. The session. The session is done.
I really appreciate this. Thank you for sharing your slides and all the information in the GitHub. Pounce on Richard. He has a lot of experience and a lot of interesting topics to talk about. So pounce on Richard before he leaves on a flight. You're here for the rest of the day, are you not?
Yes, I'm here for the rest of the day.
So yeah, once again, thank you so much, Richmond, for joining us. And I don't know what I'm talking about. Yeah, go on. I just wanted to mention lunch is that way in 52A, and we'll start again after lunch. Thank you so much.